What's up, hackers? Welcome to Attack on Tuesday. My name is Taggart, and tonight we are taking on a Try Hack Me room from Joe Helle, also known as the Mayor. You may know him from Twitter. You may know him from the Cyber Mentor content. He does the Windows attack pivoting persistence. Oh my God, Andy's here. What's up, Joe? Thanks for popping in. Big fan. Yeah, so we're taking on, and thank you for the follow, friend. Yeah, so we're taking on this room here, and we're going to follow our standard procedure for enumeration and discovery, but of course, we kind of know what's going on with it. So let's just go through the first part. So we have the box up and running, and I've started with Rust scan. And so what do we see? Well, we see 139, 135, 445, 3389. So already we kind of know we're dealing with a Windows box right out of the gate. All right, no big deal there. And then we see this weirdo here, 31337. Somebody's being cute with an elite port that's open. We'll see what's going on there. And then we've got some high up RPC ports. This is not unexpected on a Windows machine. These are the kinds of things that you expect for Windows RPC to be open, so nothing too interesting there. We sent RustScan over to Nmap, running everything, including the kitchen sink, with a SYN stealth scan. So let's take a look at what it gave us. If there was anything interesting. On 3389, we got ourselves a host name, Gatekeeper, and we have a domain name of Gatekeeper, so it's not necessarily AD joined, it's just its own thing. Did we see anything on 445? No, except Windows 7 Professional, a 7601 Service Pack 1. So, without knowing anything else, what are some things that we might go after the second we know that it's a Windows 7 box and we have SMB and RDP open? What are just some things just like right out of the gate, if it's an unpatched Windows 7 system, that we might want for easy wins in a pen test? And we've got some stuff going on. Absolutely. Eternal Blue would be a great one to check for SMB. And then for RDP, you might want to check out Bluekeep, right? Depending on if this thing has been patched or remediated in any way. So those are some things to check out. Hey, Neon, yeah. But, you know, those are some alternative paths, and you know, to be thorough, we can check them out. So just to be thorough, let's get our Metasploit console going, just to use the built-in checks for those different classic vulnerabilities, just to see what happens when we check for them. All right, so let's search for Eternal Blue first, and there's our scanner, the aux right here. So let's use 2 for our aux scanner. Options. Okay, we'll set our hosts to that right there, and we'll just give it a shot, see what happens. I doubt very much this thing is vulnerable. That's not the point, but you know, always want to be thorough. Okay, so it looks like this one isn't working for us. If we search for Eternal Blue again, we can try the use 2, right? The Eternal Romance. Or use 1, actually. We could try to attack it. And set L port. Set it to 8888. Okay. Let's show targets. Okay, that's good. Let's run it. Options. There's a lot of options. Set our port. Okay, good. Set our hosts to that and run it. Again, we're not expecting much here. We just want to make this happen just in case. And then we'll check Blue Keep the same way. Meanwhile, okay, it looks like we're getting some Ruby errors. That's exciting. Timeouts, unsurprising. I didn't really expect it to work, but that's okay. Now, coming over here, let's see what's up with that elite port, right? So let's try just a simple netcat to that, 31337. Hello? And we actually get back a response. That's kind of cool. Okay, hello, hello. So we know that there's some sort of back and forth going on here. We don't really know what the purpose of it is yet. And it's entirely possible it will be fuzzing this, trying to see what we can do with it. But, you know, definitely something to look at further. It's obviously the oddest thing in our group of ports. But to be thorough, we also have SMB, right, that we haven't really enumerated. So we can do that a couple different ways. Let's do SMB map. And I'll just give it a bogus username and password. Yep, just kidding. H. Nope, sorry. Why did I do that? I didn't want SMB map, I wanted SMB client. There we go. Okay, dope. So, even without providing in any credentials, it gave up some shares, so we have this users here. Now, if I wanted to know a little bit more about that, that's when I would go to SMB map, or crack map exec if I wanted to. And that would be H, and then let's give it a user of blank and a password of blank. See if it gives us anything. Okay, it doesn't give us anything there. So, no big deal. But if I wanted to, if I give it a bogus, let's see, give us anything? No, it's anonymous, yeah. There it is. Okay, so we give ourselves users read only. So we actually do have access to the SMB or the user's SMB share. So let's go back to SMB client and we'll do /users. And I don't have to give it anything. Okay, dope. And my terminal's a little small. There we go. Now it's not overwriting. Okay, so we've got some defaults. We've got desktop.ini. We've got a share. Let's cd into share and see what's up with that. Gatekeeper.exe. Let's get that. Alrighty. Don't think there was anything else particularly interesting in here. We'll go into default just in case there was something I missed. Alright. So into user stuff. Don't see a whole lot here that's immediately of use to me. So I am documents. So that gatekeeper.exe is obviously the interesting thing here. Now, we have a couple different ways we can look at this. Obviously, we're on a Linux system right now. Synac Codes, good to see you. Welcome to the party. So we've got this gatekeeper.exe, right? And I'm on a Linux box. Now, I can actually, maybe not right now because I don't think I have Wine installed, but I can actually run it if I have Wine32 installed. But if I do file gatekeeper.exe, it'll tell me that it is a 32-bit portable executable, right? So I need Windows stuff to continue to experiment with this. Now, I could reverse this, right? Right here, I could definitely do that. You did it once on stream with OllyDBG and Wine. Did you ever do it with Wine DBG? I was playing with that a little bit last night. And, like, it kind of worked. it wasn't like super helpful, but you could definitely, get instruction pointer breaches and things like that. Like it definitely worked sort of. And it was kind of cool. Like if you didn't have the ability to spin up a Windows machine, it was nice to know that there was some alternative option. Okay, so we've got this gatekeeper.exe, and I want to run this thing. Good news, in addition to the Kali box, I have a Flare box. So I actually have everything that I need ready to go. There's gatekeeper.exe ready to rock here. And the other thing is that these two machines are on a closed network. They both have internet access, but they also have basically not a link local, but a closed point-to-point network that I've set up for them. Real easy to do in Hyper-V. Big fan of Hyper-V as my hypervisor. And so basically my Kali box, right, has two network interfaces, one of which is my standard, and one of them is the Isolation Lab network adapter. And then Flare has a similar situation where I've got internet access because I was downloading stuff, and then the Isolation Lab. Now, Husky would be furious at me if I didn't remind people that if you're going to use this thing to actually test malware, right, just like you do in his course, turn off internet access. You gotta turn this off. That's a good safety switch. Always just knock this thing right off. Change it to not connected if you're doing this in Hyper-V. I know that his material is VMware, I think, or VirtualBox, but I use Hyper-V for most of my stuff here just because it's the most performant hypervisor on Windows. But yeah, make sure you disconnect it from the network if you're going to do evil. This isn't like evil, so we're going to not worry about it so much. But the bigger point here is that both of these are connected to this isolated network. I have given each of them an ad hoc IP address. I'm not using a DHCP server or anything. But if I run ipconfig, you can see that this Flare machine has 10.0.1.4 on one of its network adapters. And we run IPAS. ETH1 on my Kali box is 10.0.1.5. So consequently, I can get these two to talk to each other, right? I'm pinging the Windows machine, the Flare machine right now, and it's talking back. Great. Which means I can actually fire up Gatekeeper on the Flare machine, get it to run, and then talk to it from the Kali machine. So I have all my cool stuff with pwn tools, all my binary exploitation stuff that I want to have, but I've got the thing running with the debugger over in the Windows box. So let's set that up. Let's run it straight first, and then we'll attach it to the debugger. All right, so we're going to fire up Gatekeeper. It brings up a console window. It says listening for connections. Okay, cool. Now what? Let's go back over to Flare. Or sorry, back over to Kali. And we're going to NC 10.0.1.4 31337. And then let's try, see if I'm getting it. Hello? Okay, so we're getting a response. Really, really cool. And if I go over to the Flare machine, it can say that I got a connection from the remote host, handed off to handler thread, which is going to be interesting when we start getting into the debugging. Received 7 bytes and sent 16 bytes. Okay, cool. So we know this thing runs. We know that we have network connection to it. If we want to investigate it further, there are lots of things that we can do. I'm a big reversing dork, so I'm going to fire up Cutter just to look at it, but we're also going to look at it in the debugger. All right, so let's go downloads and get Gatekeeper. Okay, so again, Cutter tells us a lot about this thing. It's a 32-bit executable, right? It's read and execute. And it does have, we don't have a whole lot of debugging symbols in it here, but we do have a lot of imports. We can see some other imports here. It looks like a network application, right? Getting socket stuff. Nothing too crazy here. VC runtime 140.dll. Here's our main. And then if we go to the decompiler, let's change it over to the Ghidra decompiler. It'll be a little bit more readable. but there are so many different sub functions here. If we go to the graph, you'll see it's like less than helpful, honestly, to start looking at this from a disassembly perspective. The way this application is designed, you know, a dynamic inspection is a little bit more helpful for us. So that's what we're going to do. Now, I know that most of the material out there for dynamic analysis involves either OllyDBG or Immunity Debugger, and they're cool. And in fact, you know, Gingerroot was on here a couple weeks ago instructing us on how to use Immunity, and I learned a lot from that. But I'm stubborn, so I want to do something a little bit different. And one thing that I haven't seen a lot about is this new version of WinDBG, which is in preview, and it's available from the Microsoft Store. But it actually looks pretty cool. So that's what we're going to fire up. Here is WinDBG, the new version that is available from the Microsoft Store. Nothing's connected to it right now, but you can see we've got, you know, commands, we've got a stack window, we've got threads over here, we'd have registers. We can change up this layout if we want. I might move registers over here, actually, now that I think about it. Boom. Okay, so now I've got registers up here, and I might put the stack up here too. Okay, cool. So now I've got the registers in the stack over here. Let me change this up. So this is actually a pretty nice layout so far. I haven't attached anything, but I don't hate it. All right, let's go for it. So we're going to launch an executable. We'll fire up gatekeeper.exe. All right, it running. And it hit an int3, right? So it's the CC. So basically, it has a built-in breakpoint, and this is what our stack looks like right now, right? And the top of the stack is this do debugger break, which, yeah, here we are. So in order to actually get this thing running, we're going to hit go, and now it says debuggy is running. Debuggy, as opposed to the debugger. Now, something that is kind of neat, we'll see this as we go through this, is that you can pause it at any time. Meaning that, yes, you can attach breakpoints if you want in any disassembly, but in addition to that, you can pause it at any time. So if I hit break here, notice that the stack shows up again. Right? And I can start looking at registers. You see what's going on. And in fact, where's my... I lost my disassembly window. I'm going to go put that over here. Good. So there's my disassembly window. Pretty neat. Hey, Zarsek. I am glad you're here, bud. All right. So let's get this thing back running. Continue to have it run. And let's start doing the kinds of fuzzing that we would normally do with this sort of thing. Getting back over to Kali now. I'm going to do my normal BS with interactive Python, right? I have got my IPython window over here, and I have Pwn tools set up. So I'm going to get a cyclic De Bruin series going with 200. Now, can I do this? Could I do this straight from Pwn tools? Of course. But I'm just going to use netcat for, I don't know, just use both sides of the terminal, I guess. I don't have a good reason. But yeah, so we'll get this, and then we will paste that, and let's see what happened. Okay, bad things happened. So first of all, let's see. If we go to command, we see that we access violation, and we get a kind of a dump trace. We've got an instruction pointer that is going to be of interest to us, and we see it over here as well. And this 616D6261 tells me, these are ASCII characters, right? This tells me that we overflowed the instruction pointer, so we're on our way, right? We're on our way. So I'm going to copy this, and then with that, now, I know that if we were in Immunity, right, we could use Mona and just, like, find stuff. I don't know why I just have this like block with Mona, and it's totally me. But for whatever reason, just like learning a whole new command line when I've already invested so much in getting comfortable with Pwn tools and another stack. So I keep finding ways to not to not use it. But yeah, so what are we looking at here? We've got the registers. You can see some of the other ones have been overflowed as well. The base pointer, right, looks a little bit different, but also clearly got messed up. And here's our stack. You can see how far back these ASCII-looking characters go. Can we modify the way the stack is displayed? Okay, if we can, I can't see it. That might be in, like, settings. By the way, you can make the font bigger, and of course there's a dark theme, which is handy. But okay. So I didn't know if there was a way to like make the stack show more bytes per row, but it doesn't seem like it. That's okay. All right, so we have this instruction pointer that got overflowed. We want to find out where exactly in that De Bruin series it was. So we're going to go back over to Kali. And we're going to do cyclic find, and I think I copied that value. I did. We got 146. So it's 146 bytes to the overflow. Okay? Meaning that after 146 bytes, the next bytes are going to start overflowing into, in this case, the instruction pointer, as it turns out. We don't know what else is back there on the stack, but definitely that. So we're gonna save that. We're gonna save overflow len to be 146. I'm gonna fair warning, I'm gonna be making a few more typos than usual tonight because if I sound different, it's because I finally put the microphone like in front of my face rather than over to the side. But of course now I can't see the keyboard, so I like have to do touch typing. So I'm keeping myself honest in that regard, but it's going to be a learning curve for a second. Okay, so we've got overflow length 146. To confirm that, we're going to restart the debugger. GoPro, thank you so much for the resub. Appreciate that, friend. All right, we're going to restart this thing. Okay, up and running. And we have to hit go to actually make it run. And back over to Kali. So what we're going to do now is we're going to say, payload equals A times overflow length, right? And then we'll do payload plus equals, and we'll do 4Bs, right? So if we've gotten our math correct, the instruction pointer should be 42424242. Okay, and we'll do con equals connect 10, nope, yeah, 10.0.1.4 31337. Now I am doing it through Pwn Tools just to show it that way. Okay, and then con.sendLine payload, and then hey. Okay, so our math looks good. We know how to overflow the instruction pointer. We know that our overflow length is 146. Now, how far back does our stack go? How much space do we have? We don't really know yet because we haven't tested that. We can see that the base pointer is a bunch of A's, right? The stack pointer is fine, though, right? Now this is where, again, I would like, normally, if I could, to use the static analysis to help me out a little bit, because if I knew what function we were in, I could find out, and we can kind of find out what function we're in. Maybe I could find out how big the stack is by just doing some math here, right? Without having to do dynamic analysis. I could find out how big it is by just subtracting here back to the stack pointer. But not gonna happen, or not easily anyway. Plus, we don't have to. There's another way to do it. So we're gonna restart this thing. So obviously, we overflowed this here, but I want to find out. What it takes me to get there. So restart this. And by the way, if I'm sounding authoritative, it's just because I'm talking through my process. I am definitely still learning this stuff. Okay, so the real experts in here, obviously, the mayor and Zarsek, Neon. You know, you guys keep me honest, please. If I'm doing something in a very silly way or straight up wrong, please let me know. I'm definitely still very new to this. Okay. So what we're going to do is we're going to recreate that connection. Wait, did I make it run? Go. Okay, now it's running. Back over on Callie. Sar. But I saw your stream on doing the ROP Emporium stuff, so as far as you are the SME in the room as far as I'm concerned. Well, you know, if Joe was still here, you know, he wrote the dang room. So I guess he wins, but this is what we call learning in public. All right, so we're connecting con.sendLine, and we're going to send cyclic. Let's send a bunch. Let's send like 500. Okay, see what happens. Okay, that went poorly. Obviously, we got the same thing in the instruction pointer, but what I really want to know... Yeah, look how much more stack there is. Right? And so what I really want to know is if I got... Okay, I didn't get there, though. What is this? Huh. Okay. So, right, obviously, I'm not going to hit the stack pointer because... of the way this is built, right? Stack pointer's on the other side. But I definitely hit the base pointer. Let's restart this thing and... Right. Stack pointer isn't on the stack. You overwrite the base pointer. The stack pointer's on the stack. It's just in a different spot. Or I should... No, you're right. I'm sorry. The stack pointer's not on the stack. It's in the register. Right, of course. It's modified. the previous base pointer is put onto the stack. Of course, right. And this is why I like this, right? Because if we knew what function we were in, we could see here. Well, I don't even, so sorry, with WinDBG, I could just pause it at any time. And so now I can actually do some math here. So I can just do some math here between this, where I want to do SP or BP minus SP, right? Yeah. But we know that we have more space than that. So what did I make a mistake on there in my reasoning? Because I just did a well, actually, maybe I didn't, and it's just that we're not in the right function, because we don't know for sure that we're in the right function. Let me go to strings here. So if we go to the hello format string, let's show this in the disassembly. Okay. Ha 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 ha. Okay, so we actually found pushter hello. Function add stack pointer. C. Zero x94 is my hex math is pretty rough. 148, which tracks, right? Because if it's the that's pretty close to where we were. So based on that, we're in the right spot. Okay. Push that to the stack, and then this is probably the send, right? And then looks like feeding bytes into our buffer for send. And there's a return. And okay. So we have 140. I mean, this tells us what we knew before, but then what happens, right? Because if we overflow past that, what are we starting to get into? Is the question. So let's send that mass again. And actually this time, just so it's easier to read, we're gonna send just like 500 A's and see what happens. Rootkey, thank you so much for the follow. All right, come back over to WinDBG. Obviously, we see a bunch of A's. And let's see if our mim_dump gives us any more information. Okay. Right. The trick is, and this is the part that I'm confused about, like, the truth is that for a Windows bit of shellcode, and presumably that's what we'd be using, 140 some bytes isn't like a lot to work with, you know? And I think if my reasoning is correct, we should have more space than that to work with, right? The question is where it's coming from. Because if we're writing past, right, the base pointer, we're getting into other memory. Or not, I guess. So the question, and this is a question for chat as much as for anybody, like, how do we determine how much space we have to fill up, to overflow not just the instruction pointer, but the stack itself? You know what I mean? You can own all the memories on this one. But how do we know? That's what I want to find out. I guess the entire thing is executable. You should just be able to extend your payload with C's or something. Yeah. That's kind of what I mean. And in fact, even with just A's, like, look, we definitely got... Oh, there's no more memory on the device. Okay, yeah. So this is about... I think that's right, Joe. So basically, this is about how the stack works, is what my question is getting at. And you're absolutely right. So basically, remember that... let's go to Cutter here. You know, let's take a look at the disassembly. Look at these memory addresses. This is a little small. Let me see if I can zoom this in for folks. Yeah, look at those memory addresses. So this is the contiguous section of code right here. And there are different sections. You know, we can go up to the text section. But, you know, these addresses are, you know, they are what they are. That being said, the stack is nowhere near that. In fact, let's restart this thing now that we've killed it and take a look at that just to be clear about it. Okay, running this thing. Now, let's pause it. And let's take a look at these. So, look at the addresses for our instruction pointer. So there's 77A40, right. So there's this address. And then our stack pointer or our base pointer, totally different place, right? They're nowhere near each other. And exactly right. So basically, despite the fact that we're in a stack frame, which is what we were looking at in the disassembly, right? The 148 bytes that we're talking about is essentially the stack frame, right? That is bookended by the base pointer and the stack pointer. We're in memory space that is open season, basically, is what was Joe was saying. And so we can go past it if we want, if necessary. So, that's cool. The trick then is, but if we only have... The EIP will be allocated on the amount of bytes required by the program. That's a good question. I don't know. I mean, I don't know how the operating system determines where to instantiate the stack. And also, some of that's going to depend on... So if your instruction CMD, you would have the amount of space required to execute that. Right. That's right. And then whatever the addresses are, though, are going to be arbitrary to a degree, right? Because some of that is about whether address space layout randomization is enabled, and a few other things, right? And as Al told us last week, even with address space layout randomization, it turns out that ASLR is only going to be for within the context of the code section of our program. Any of the stuff that is pointed to by the whatever the Windows equivalent of the global offset table is, the DLL imports, essentially, the imports are going to be constant per session. Pretty crazily. The actual code section of the binary isn't randomized either. But its offset is randomized, is it not? It would have to be. Otherwise, what's the point? Oh, right. That's position-dependent execution. Got it. Okay, so coming back to the issue at hand here. We have a lot of space to work with. The trick then, though, is if we only have 148 bytes to get to the... Well, 146, and then we've got... Or sorry, 146, then the next 4 are going to overflow the instruction pointer. Yeah. Hang on. How many to the base pointer? Because yes, we can overflow the instruction pointer, but we have to know where we're going, if that makes sense, right? If we were going to overflow the instruction pointer and then, perform like a NOP sled within the space that we are working with, right? We only have so many bytes, but we can go past that, right? In order to do that, though, I think that we have something else that we need to do. We have to overflow the base pointer, and then with like a specific or like a guessed value. We're still going to do kind of a NOP sled, but it's going to be at a different position. So let's keep going here. So what we're gonna do is let's let me try something. Sorry. brain broke for a second. You need to overflow the instruction pointer with a jump ESP gadget that will start executing whatever you write in the overflow after the overwritten instruction pointer. You only need to overflow the instruction pointer with a jump ESP gadget that will start executing whatever you write in the overflow after the overwritten instruction pointer. So I understand mechanically, Czar, what that means, but here's where I'm falling off there. So the jump to the stack pointer, but the stack pointer, like, don't we have to convert the stack pointer into whatever you write in the overflow after the overwritten instruction? The stack pointer still points to stack. Oh, right. Okay, Got it. Yes, yes, yes. So this isn't ROP really. But well, yeah, it kind of is, right? Does this qualify as return-oriented programming or not? We are using a gadget. And for those wondering, so a gadget basically is a piece of assembly, right? That's going to do a specific operation for us to get us back on track or load information into specific registers that we want. Is basically what we're doing. It is kind of the jump ESP is a ROP gadget, but then we jump straight to instructions we directly wrote. Right, right. So it's like a one link ROP chain. Okay. Okay. So couple ways to do that. So again, I'm not super familiar with WinDBG, so I'm curious what we can do here in the disassembly. Can we find anything at all? Can we search? There's a scripting engine. Interesting. There's a JavaScript scripting engine in WinDBG. Now I'm just wondering if there's a way to exploit that, but that's a different issue. Data model. It's cool. I feel like there's a lot of stuff in WinDBG that would be useful. Oh, look at this. It's got its own CLI here. I don't think it has a whole lot of power, but that's okay. So look, we've got Cutter here. And we can search. And sure, we can actually use Cutter to search for specific opcodes. So if we search for jump ESP. What? Nothing. Interesting. There's a bunch of jumps, but it's interesting that it's not finding the jump ESP. Like, presumably it's in there. Oh, hang on a second. I wonder if it's like... How about jump RSP? It shouldn't be, because, right, it's a 32-bit executable. Hey, Husky! FFE4 jump ESP opcode. That's how we use WinDBG? I can't tell what you're telling me, Husky, unless those are chess instructions. Yes. I will. There's a bunch of degenerates. I think you're missing something about ROP chains. Yeah, I'm sure that's true. Oh, search for FFE4. Those are hex bytes. Right. Okay, I got you. Interestingly, like, I was searching for... Oh, wait. Hold on a second. There's a search for ROP gadgets? Okay, let me try just hex string or okay. Interesting that that worked and that the other one did not. Okay, let's save that. C3. Is it? Am I blind and I just can't? I'm double clicking on it. Show in disassembly. C3. 1C2. Aha! Okay, well, either way, we'll copy the address and we will save it in Cali. To jump ESP equals P32. That address. The way finding rock gadgets works disassembly backwards from a return instruction, not forwards from the beginning of a function. That I understand, Sar. Yes. So if you look at all the instructions of a binary, those are not at all close to the gadgets you can find in there. Okay, that's right. That makes sense. Right, because arbitrary series of bytes can be translated into opcodes that won't just show up that way. Got it. That's helpful. Okay, so we've got our jump ESP. So and in fact, can ROP Gadget work on portable executables? I actually don't know. Yeah, it can. Hasn't even gotten to the challenging part of this one yet. And in fact, we can do that with Pwn tools too. I think. Yeah, we haven't talked about bad bytes or anything yet. He's probably talking about the privilege escalation to root. Okay, that tracks. 80414C3 tracks with what ROP Gadget tells us about. So we've got our jump ESP. Okay, so we want to do something like just like filler, right? And then now we need some shellcode. Filler, jump ESP, actual instructions. Right. So we need some instructions. So we're going to do MSF Venom. T. Windows. X64. Interpreter. Reverse TCP. You just test first with /XCC. All right, yeah, fair enough. Fair enough, fair enough. Okay. Let's restart our debugger. Sorry, you want to say why we're using that byte, the CC? I think I remember why from doing this with Ginger Root. It's a software breakpoint, right? The debugger is going to interpret that as a breakpoint. All right, let's restart this thing. And go. Is it running or not? Yes, it is. Okay. Back to Cali. Okay. And then con.sendLine. Payload. Okay, let's see what happens. It paused, I think. We hit NTDLL debug breakpoint, which would suggest that that's indeed what has happened. I mean, I think so. This thing isn't really responding the way that I would expect. I'm gonna kill it and bring it back up just in case, because I don't know, it just seemed weird. Okay. One more time, just to confirm. Ah, see? It wasn't actually doing the thing. Now this looks a little bit closer to what I would expect. Right? So we hit a breakpoint. We got our register showing up here. Base pointer looks, totally borked. But everything else looks good. Stack pointer looks good. And the stack pointer here. And then there's our... And then hit our next breakpoint. Our instruction pointer is incrementing. We're stepping, but we've got all these C's and then the rest of our stuff. So good so far. Okay. Neat. With that done, then let's build ourselves some shellcode. Now we're gonna give it some bad bytes. Let's do because I know there are common bad bytes, right? Obviously, the null byte is going to be one of them. And I know that we, maybe we can test for all of them. Yeah. Or null bytes mess with Sterling. So null bytes are bad news, and then do we in MSFNM do we comma separate the bad bytes, or do we just give them to them in series? We'll try it with a comma. And L port equals, hang on a second. Yes, I am 5. Port equals 8888. Yeah. Cool. Okay. Whoa. Gigantic. 2688 bytes. I guess Meterpreter is giant. I guess we don't need all that, but is this the stage? I thought the staged was smaller. Imagine doing buffer overflows with Python, not Ruby. So the mayor, tell me about doing buffer overflows in Ruby, because I used to be a big Ruby guy. I used to write all my Mac shell scripts in Ruby because it was a much saner way of doing it than in Bash, I found. Is it just in series? Okay. Metasploit uses Ruby. Sure. Generic none failed. Okay, but we've got the XOR encoding worked. The payload says 551 bytes. Okay, that's sane-ish. Okay. Using prime makes fuzzing is super easy. Interesting. Okay. Now, here's a cool thing that we can do. Okay, I'm not going to click on the write-up for this just yet. But I will take a look at, because I know that's your site. Yeah. Okay, so here's something cool though. With interactive Python, which is kind of my friend here, I've got the Python in here. So what I can do is, let me close out of this. If I do import shellcode, actually, I already have something called no, I don't. Check this out. What? Shellcode.buff. I already have the payload in there because it's in its own file and these are in the same directory. So that's a fun little trick that I like with interactive Python. Okay, so we'll say payload. Oh, actually, you know what? Use exploits multi-handler. Set lhost 10.0.1.5. Set port 8888. Set payload. Windows. Cool. Okay, so we've got our interpreter listener ready to go. Now payload equals a times overflow length payload plus equals jump PSP, then payload plus equals, hoping we don't have any stack alignment issues, shellcode.buff. Okay, and let's restart our Gatekeeper. Okay. And con. Well, that didn't quite work. Let's see what happened. So I've got a violation here. This looks okay, though. And the stack looks... Oh, wait a minute. Wait a minute. I think I know what I may have done wrong. I mean, I'm sure I did a bunch of stuff wrong, but one thing for sure. I used a 64-bit payload, and this is a 32-bit executable. I should not be seeing addresses that look like this, right? That's going to mess me up. All right, let's go back and correct that error. Okay. Okay, that's fixed there, and now let's fix it here. Dang it. Let me restart the, Yes, yes, I did. I packed the jump ESP. Which I'm going to have to redo here. See? It was packed. Oh, from home import. Everything. Great. Now, import overflow len. This is also nice, right? When I restart it, it has my command history, so I can reproduce stuff pretty quickly. I like that a lot. Now, import shellcode, len shellcode .buff. That's better. Okay, payload equals payload plus equals jump ESP, and then payload plus equals shellcode.buff, and then con equals hey QHPix con.sendLine. Oh no, I forgot to run the listener. Let's restart that. That may not have been correct either, but I want to give it every opportunity. Nope. So let's see. C0096. I feel like we still have null bytes in here. Okay, no null bytes. I'm wondering, and I'm totally, I was gonna, you know what's I was just thinking, like, I don't know what I'm talking about, but don't we, for like is stack alignment something to consider here? And okay. Perfect. Perfect. All right, cool. So let's do that. A couple knobs in front of the shellcode. So payload plus equals, what do you think? 10? $50. Okay. 10 works fine? Okay, cool. Then, all right, that's still running. Let's restart the process. And you know what? Now that I'm thinking about it, let me add some time to our room. And I wonder if it actually was up, because I have experienced that TryHackMe's timer is not super accurate for me. Okay, looks like we lucked out there. But I've definitely had TryHackMe seconds not be real seconds. I don't know if anyone else has experienced this. Oops. Okay. Ah! What did I do wrong? Oh, go would be good. Let's try that again. Awesome. Con.sendLine. Payload. That is a great feeling. And I want to thank everybody so much, especially Joe, for the help on even just this first part. That's really cool. Okay, now, obviously, we're just getting started because this was on our test. Now we got to go deliver this thing to the real deal. What debugger am I using? So, QHPix, I wouldn't say that there's a debugger that I do use because I'm too new to this to say that I have a preference. But tonight, just for test, I was using WinDBG. And I don't hate it, but there's a lot I think that I need to learn about it. I do like that it's quite clean. But there's a lot, I think, it has a really cool scripting engine under the hood. Yeah, I think there's a lot to learn about it. And I have to say, the fact that it is kind of available with like minimal effort is really interesting. But yeah, we're just playing with it tonight to see how it goes. I don't think it's the nicest one I've seen. Obviously, it doesn't have the depth of development behind it that like Immunity does, or like the community aspect to it. Yeah, OllyDBG is really cool too. And this is Flare, so I actually have access to all of them. I'm pretty sure Ollie's on here. I know that Immunity is. I have access to all of them. But yeah, because I'd never really gotten my hands dirty with WinDBG, but I was curious about it, that's what I was using tonight. Okay, so we are... Let's rerun... Oh, nope, that's wrong. Two. We got to change up the L host 10.13.7.20. And in fact, it's at this point that we would maybe start writing this out to a Python script rather than relying on IPython. You know? So we can use the shellcode that we have as a starting point. Run that as a job just so we don't have to worry about it. And then come over here. And then We'll vim exploit.py. Okay. From pwn import everything. And then we'll use some of what we have over here. Ah. Okay. Then we'll say overflow len equals 146, which we knew. And then let's just get this. Whoop. Wait, what? What, the Vim stuff? We actually did a whole series on Vim a while ago for Hack Summer. If anyone's curious about that, we cross-stream everything to YouTube. And... Okay, so we've got... Yeah, so basically I've got two tabs open in Vim, right? One of them is the shell code, one of them is the exploit I'm writing, and I just did a little bit of copy paste to get that over there. Okay, and now we could make that a one-liner if we wanted to, but you know, whatever, it's fine. So we're gonna say payload equals a times overflow len. And then payload plus equals jump ESP. And now we know that we're going to do some padding. It's 10. And then payload plus equals buff. And then let's set up the target as a variable up here. And we'll do it Python style. So constants will be all caps. I'm so broken now with like nim and some other like YAML stuff. I keep having to align all my spaces. It's a problem. By the way, if you're interested in nim, stay tuned for tomorrow's stream. We are continuing building out the nim buster. Went out from sys.args. So sys.argv, QHFix, we absolutely could do that. If we wanted to. Yeah, for sure. Right, we could do target equals sys.argv1, port is sys.argv2. For sure, if we wanted to. Okay. And then we'll say con equals connect target port. Oops. Python gotcha. I got to convert this one into an integer. Okay. And then on dot send line payload on.close. And we'll put in just a little bit of print payload. It's no John Hammond script, but it'll do. By the way, I don't know if you caught it. This is my favorite thing to teach new Vim people. Right? To save and quit in one move, right? In one keystroke or one letter. is X, colon X, is save and quit. I like to teach people how not to use Vim. Hey, you know, that's fine too. Infinite diversity and infinite diversity and infinite combinations. That's what I say. Honest to God, the reason I started using Vim so much was because I was too lazy to change the default like git commit message editor to Nano. And so I was like, I guess I gotta figure out how to get out of this thing. And then I just started using it for other stuff. Okay. And then... rats. QH Pix, this is T-Mux with a not that customized Neon. Don't start a text editor war here. Did I change my shellcode? Oh, good catch. Let's find out. I did not. Yep, good call. All right, let's try that again. Well, cool. Now I get to do more fun Vim stuff. Okay. All good? All good? Hey! Okay. Now we can get to work. Okay, first of all... hypothetically, we could also use a call ESP instruction. That is true. Halfway there. Yeah, we'll see. Ah, the buffer overflow in this room is credited to Justin Steven and his do stack buffer overflow good. And in fact, going over to Flare again for a second, something that we saw that was actually pretty cool in Cutter was that itself. We saw, and actually I think we saw it in the stack when it was running too, that there was like a function or a call to do stack buffer overflow good. I think there's something in here that says that, but for sure the PDB is in here. So if we go to Cutter and go to strings, yeah. I love stuff like this. When you find the PDB still in here, that's really interesting, right? I love it when malware authors leave this in here. Right. You can strip this out, but you have to set certain things in the project config, or give it certain file. If you do MS build, you can give it certain flags to not include that. Okay, but uh-oh. Seems like I might have If there's Defender on here, I'm gonna have a good time. Yeah, that's what I thought. I'll give it a few more seconds. So, but let's game plan here with our downtime for a moment. So we get on the box. Let's assume for a moment that there is a there's something that's killing this process, and I want to get off that thing as soon as I can. So for that reason, I'm going to create another handler. And I don't like this. I don't like the staged payload. So I will use the unstaged payload. And set a port to 8889. We'll run that one as well. And then we're gonna create .889. Our output's going to be MT, and the F is going to be XC. I'm so used to making else. Nope, mt.exe. And I'm not too worried about that. Make this unstaged. Good. Okay, now, also assuming that we'll host a little web server for ourselves here. Now, assuming that this is Windows 7, which means like the easy mode PowerShell stuff isn't there, we could do the http.web client, but we can also use certutil, right? So let's go get and we'll just set up the string that we want to use here. For easy reference. So it's going to be, I got to fix my completions engine, but 10.13.7.20 8000/mt.exe. We're going to make it mt.exe. So we're going to save it to, okay. Yank that line. I think I yanked that line. Oh. Certutil.txt. Cool. And now, let's try this again. See if we did any better. QHPix asks, what does a PDB do? As far as I understand it, the PDB is what contains the debugging symbols, right? So if I had the PDB, I would have all my function names and everything else in there. Is the box alive? I mean, I think so. in theory, I'm more than happy to restart it. Yeah, let's just do that. Not so great for a pen test, but for this learning experience, eh. So, right. The first thing we want to do is get off of this this interpreter session and try to, since we suspect we're not dealing with Defender, we'll try to get another kind of presence on there just for a more stable session. We could also, I guess, migrate our shell if we could make that happen. So one or the other we can try to make happen. Or migrate our session. And then we're talking about Windows 7, so, you know, we have a number of different escalation paths at our disposal. Plus, of course, standard enumeration, things like services, file paths, the usual. Actually, this is a new Kali box. I do have WinEnum, though. And WinPeas, if necessary. Give it another minute to boot up. It is a Windows box after. Oh, God! You know what? I think I know what happened. The box wasn't alive. And does anyone want to take a guess as to why? It was the Try Hack Me curse. Yep. It's not 2 hours for Windows boxes, everybody. It's 1 hour, because after the evaluation period... Oh, no. It's a Windows thing. Yeah, that's right, Husky. It's after the evaluation period for the VM ends, right? If it's not connected to the internet proper, if it can't phone home to Windows, actually, even if it can, after an hour, it shuts down, and there's nothing you can do about it. It'll just die. And because the Try Hack Me Terminate button, the status is naive, it's not heartbeating the thing. It's assuming that the terminate will terminate if it's on, but it's not like doing a constant status check. And so basically the machine dies without you knowing about it. Yeah, it's a huge problem. And it's something that you run into with basically every older than 90-day Try Hack Me Windows machine, because the evaluation period has expired and no one has gone in and rebuilt the machine. I mean, it's, you know, it's a licensing thing. The thing that I would very much like is for there to be some sort of ability to, like, if it's an AWS issue. I mean, I run into this with my VirtualBox machines too, right? Like, I think it's just a Windows eval issue. But what would be cool is if Try Hack Me had an option to essentially provide a Packer build, exactly, QHPix. Like, if you created like a Packer template where it could rebuild it for you and off of a new install of Windows. Their licensing on THM is supposed to use AWS. That's interesting. You know, I've only played a little bit with submitting THM or THM boxes, but like, don't you have to give them like an OVF or something? So it's like your build, right? So if it's your build, then your evaluation, because you're not hitting their KMS server, presumably. That would be dope, though, if you could like have some sort of hook on there that like hit their own KMS server, and it's like, yeah, now you're fine. That would rule. Does Hack the Box have the same issue? I honestly don't know, but I'm gonna gently, like, tentatively say yes. I feel like I have encountered this with Hack the Box machines as well. It's not just yours, though, Joe. Like, lots of people's machines have this issue. In fact, I have encountered this with literally every Windows machine that I do on Try Hack Me that is not brand spanking new. All right, let's. Oh, nope, new IP address. Birdie tells me they encounter unlicensed boxes in a certain well-known certification company's exam boxes. Well, well, well. By the way, you know, I should say, I saw your post about being disappointed in ELS, and I have to tell you, I strongly agreed. I just did the threat hunting certification, and, you know, the threat hunting stuff is kind of few and far between when it comes to certifications, but man, first of all, I had to bug them after 30 days to grade my thing. I feel like they're definitely understaffed and overworked. But it was like, I don't know, I felt like there were some definite shortcomings to the instructional material there, some disconnects that I found problematic. Yeah, I don't know. TLDR, I appreciated seeing your take on that, and I agreed with it. Hey, hey. Okay, sessions 3, shell, and do I have this thing running? I do. Okay, let's cat the... Let's do this as fast as we possibly can before this thing dies. Hey, look at that. Okay, so now we have our other interpreter session that's based on an on-system payload. Okay, now I feel a little bit better. What are we looking at? We got cmd.exe, we've got dawm.exe, we've got explorer.exe. Okay, can I migrate to 1400? NatBat user is named after my youngest daughter. Her nickname is NatBat. Oh, that's adorable. Is the priv-esc also a buffer overflow? Well, I don't know. Let's do the usual. Oh, wait, I'm still in. Let's try that again. Okay, so let's see. I don't have increased working set. So, nothing easy there. I always confuse the SC syntax with the scatasks syntax. All right, let's see if there's anything fun in here. If I need to load access check, I will. Because I did Heath's Windows Privilege Escalation course. less try harder here. All right, let's not make life too hard on our self-design. Let's upload. Haggard. Oops. I love how far down this thing is. It's so great. Actually, you know what? I should run sysinfo first. Okay, it is 64. Even though the binary was 32-bit, it's a 64-bit system. Where am I? Oh. Oh, Metasploit. All this stuff should be, you know, getting caught by... That not run? Unfortunate. Oh, right. That pops up a separate window, doesn't it? That's not helpful. I hate doing this in without... I mean... Yeah, that's what I thought. Okay, let's I always hate this. I don't like, because I can never remember that. Let's just do this, right? 0 set session 4. This is a pretty naive run. Okay. I bet this isn't going to work, but we're going to do this anyway, just to be thorough. That's fine. Let's go back to our session 4. And let's get back to our shell. And let's do some proper enumeration here because... it doesn't seem like... the way we want to go. What kind of work do I do? I am a blue teamer, technically, during the day. I'm a cybersecurity analyst for a major healthcare organization. And what that means in practice for me every day is I do everything from log analytics to sometimes defer stuff, light defer stuff, to vulnerability management. And actually, though, because I have this kind of this red teamy kind of lean, I spend a lot of my time doing web app pen testing actually, because before I did this, and I was a teacher actually before any of this, but then I spent some time as a web developer, and so I bring that to bear doing web app pen testing internally for the organization. It's a lot of fun. But that's why I'm trying to learn this stuff, because the Windows attack path and the buffer overflows, like the binary exploitation, is an area of growth for me. Have I ever had a major incident? If I did, I couldn't talk about it. But at my time at this organization, there has not been a massive breach. Have we had attacks? Sure. We've dealt with them. I will say, it was kind of funny. I started in December of 2019. And does anyone know what really cool vulnerability came out in December of 2019? LS, come on, no, I think that was a little bit beforehand, although you're the same year. Bluekeep was behind that. SolarWinds was later. SolarWinds was 2020. I'm gonna put... this one's burned into my memory now. Yeah, SolarWinds was 2020. December of 2020. So a year later. 2019 19781. The Citrix ADC remote code execution. Yeah. And we definitely saw like a lot more traffic from China that month than we were supposed to. It was an interesting time to start looking at, a big organization's network footprint and understand how it was going to get targeted. Okay, I really would like to run WinPeas, and I'm not... I guess it has to be in PowerShell, but I'm not entirely certain why it's not running for me. It doesn't need PowerShell. Yeah, that's what so I'm a little confused as to what's going on here. But I will upload the x86 to see if I do any better. You don't need the /? Okay. Oh, right. Right. Ah, that's what you were saying. And yet. Yeah, I don't think the // was going to hurt me. Well, I mean, I should. Never been a problem before, but anyway. Hello. If this is what I think it is, I've been dodging this on another box forever. Because I didn't want to do the manual decryption. Oh, good. Oh, good. Is there or is there not a Metasploit module for this? Okay. Oops. Oh. That's what you want to see. Well, well, well. That's fun. This part literally killed people when the box released. There was some other box that did this, and it like walks you after reading the write-up. It walks you through doing the manual decryption, and I was like, not doing it. Oh man, okay. Right, okay, here we go. Because this is... Okay, so this looks familiar to me. And what this means is that we are going to have to do this. What is it, like, what is it called? Like Firefox Decrypt, right? Oh, shit. Yep, right there with you, bud. Good, good, okay. Well, we can exit out of IPython. And the usage is what? Folder containing profiles.ini. So that would be and yeah, it's not a valid profile. Wait. Okay. Nope. Okay. Now we have to rename these things, I think. So cert9.b 31909 is cert9. Thank you very much, Fish. 844976 is what? Cookies.sqlite. $720,827 is key4. Okay. And then finally, logins.json is this fellow. Hey, that looks better. You should be able to change. Yeah, you can do it the same from Metasploit. It's just that I was taking advantage of Fish's fuzzy completion to make that a little bit easier. That's why I was switching back and forth. Because I could just like type a couple of numbers and hit tab, and Fish would be like, "Oh, I know what file you want." Okay, so now it's THM Gatekeeper profile. Hey! Yeah. I kind of started my life in IT seriously after doing, education stuff for a while. Basically being a Linux dork. And that was a huge, huge help, honestly. Okay, so we have a password for mayor. Do I not have Romina installed? Shame on me. Jeez, okay. Also, man, there's so much that I wanted to talk to you about, actually. I meant to give you a huge shout out, not just for the content in the pivoting and persistence course, because it's killer, but also your lab setup, dude. I was so inspired by it. I really appreciated everything you did to script out creating the domain controller and everything. Really, really neat. I'm trying to put some of that together into my own lab setup. Oh, I bet. Yeah, it's so intricate. Even figuring out how to do all that stuff via PowerShell and then automating it, yeah, crazy. What I'm trying to put together is like, actually, is it visible at the moment? I haven't advertised it, but... Oh, there's nothing. Oh, yeah, no. There's a test branch. So I'm trying to put some of this stuff together here. Well, basically what I want to do is produce a contained lab with pfSense as the router and have an isolation network for malware analysis, things like that, and then a general network that has, whatever you want on it. And then pfSense provides DHCP, and then the domain controller will provide DNS. And basically, rather than putting guacamole on everything, I'm going to have a single jump box that has access to the whole smash. But what I want to do is have it buildable from first principles, right? So rather than relying on even Vagrant boxes, because I don't really trust Vagrant and it doesn't like Hyper-V at all, basically create Packer builds for everything, and then I'll script it out so that you can have it build to target either VirtualBox, VMware, or Hyper-V. And then because these are all pretty much modular, other than pfSense and then the Ansible to create roles for the different machines, you can bring these up and down as you need. We'll see what happens. Packer is like, I don't know if you've played with it. I don't know if anyone in the room has played with it. Packer is like Game Genie for virtual machines. It's ridiculous. Like, hold on a second. Where's the Ubuntu one is hilarious. Look at what you have to do to make it work. You literally have to send it keystrokes, right? These are all backspaces. You are creating keystrokes in the installer to produce whatever you want. So basically you're removing the init RD line, right, with a bunch of backspaces, and then you're making it retype itself. Or the pfSense one is even stupider, where you have to do like, yeah, like enter, wait, enter, wait, enter, wait, and like tab. You have to do all this stuff just to make the thing work. The Windows one also very silly, but yeah. So pfSense, one of the things I appreciated about it though is that pfSense actually can be fully configured with a single XML file, but you just have to make it first. So basically what I did was I did this whole all manually, and then I extracted the config XML. And basically what you do is you make it, you run through the install however you want. It doesn't really matter. And then at the end where it's like, yeah, give me the shell, you just SSH. No, you, because Packer sets up an HTTP server, you basically have it pull down the config XML into place after you've installed it, and then when you restart it, everything's good. But yeah, it's each one of these has been its own unique kind of weird. Okay, let's right, we have your password. Let's see if we can actually get in here. Oops, that's not where the password goes. Mayor. And wait, what just happened? Oh, it's there. It was just being... Hey, Big Mama Tristana. I mean, how long do I have to wait for Gatekeeper Netbat to respond? Quiet Side of the Moon, thank you for the follow. Yeah. We, institutionally, we dropped that down way lower than 30 seconds. Hey, Windows Activation, what up? Hey! That was super fun, and I learned a whole lot. Quiet Side of the Moon, yes. It is. Wait, did I forget to put in the user flag? Let me go get that. Yeah, that was really cool, and thank you so much for hanging out. That it means a lot. I really mean it. Um, been a big admirer of both everything you've been doing for a while. In fact, you were one of the first guys I watched when I thought about getting into streaming. Um, and everything you've done with Heath recently has been just awesome. So thanks a lot, and friends, I hope you all enjoyed this. I know I did. Um, we're gonna say goodnight now. If you're new to the stream, Tuesday nights are Red Team. Wednesday nights, same time, 5 p.m. Pacific, programming. And tomorrow, going to be a lot of fun. We're going to build a directory brute forcer, like GoBuster, in the NIM programming language. We started this last week, and now we have parallelism figured out. And so it's going to be really cool, and I think it might actually beat Ferox Buster for speed. So if you're interested in that, there'll be a good time tomorrow night. And then Saturdays, we do Blue Team at 10 a.m. Pacific. So threat hunting, forensics, that kind of stuff. But for now, we're going to say goodnight, but we're going to check out the hack list. If you don't know about the hack list, that is where the streaming community for information security hangs out. We are Legion, so let's see if there's anybody... Oh, GoPro is streaming right now? Well, we're obviously rating GoPro. That's obviously happening. Yeah, no, absolutely. Hang out anytime. You're very, very welcome. All right, let's go give GoPro some love. All right. Well, friends, until next time, be good to yourselves, be good to each other, and happy hacking.